Now I'm going to write a program demonstrating what happens with over and underflow. I've began my program with the standard environmental setup, and now I'm ready to begin creating variables. So I'm going to create several different variables here with different memory sizes, and I'm going to make most of these unsigned because it's easier to work with unsigned variables when I know that the smallest possible value is going to be a 0. Now I've created 5 variables. And if you're coding along with me, you'll want to pause and add these variables as well. I have 3 different sizes of integers, the short, the int, and the long. I'm using the unsigned data types, so the smallest value will be 0, and I've initialized these variables to 0 as well. I also created 2 floating point numbers, and I'm going to look at when they become set to infinity as well. I'm using a float, which is single precision. I've initialized that to 10, and I'm using a double or double precision number, and I've also initialized it to 10. But first I want to work with the integers, and then we'll come back to floating point. So when I'm working with these integers, I want to see what happens if I try to subtract 1 from these numbers, and we're already at the smallest possible value. So I'm going to put a comment here about what I'm doing. So right now, or not the max, the min, rather, and it's going to become max. So I have a value of 0 on these variables. If I subtract 1, I don't have any place to go, so it's going to wrap around to the largest possible value. So it's going to go from the minimum value to the maximum value. So I'm going to say min short minus equal 1, min int minus equal 1, and the same thing with min long. So this is subtracting 1 from these values and reassigning the new value to these variables. And this will be what we call underflow. So I'm going to go ahead and put in a cout statement to display this, and we can see how this looks, and then we'll look at some other things. So I'm going to say cout integer, capitalized I guess, integer underflow. Boy, I can't type today. And I want the next thing to go to the next line, so I'll just put my backslash in, which is my escape sequence for my return character. And I'm putting this comment here because once I start putting different numbers on the screen, I'm going to get confused about what they are if I don't label it here. And now I'm just going to show each of the 3 integer values on a separate line. Oh, I should have done short up there. Let's change that one to short and make this one int. And then finally the min long. All right, so when I run this program, we will be subtracting 1 from the smallest possible value. The value is going to wrap around to the largest possible value, and then we're going to display the values on the console window. So I'm going to go ahead and compile and test this program. And here's what I get. For the short, I'm seeing its value is now a little more than 65,000. I told you the maximum range was about 64,000. So again, we're not so concerned about the precise number here. The int became about 4 billion. And then the long int became this very long number. It has a lot of digits in it. So what I'm seeing now are the largest possible values assigned to each of these variables. Now that we've seen what happens with the underflow on each of these variables, I want to create an overflow situation. Currently, each of these variables has the maximum possible value assigned to it. So what I'm going to do now is I'm going to add a number to it, add 1, and that's going to take me all the way back to the bottom. So I'm wrapping around again. I'm going from the highest to the very lowest. So I'm going to put another comment in here indicating that here's where I'm working with overflow. Value is, so right now the value is at the max, and when we do overflow we're going to go from max to min. And now with each of these variables I'm going to add 1. So I'll start with the short, and then I'll go to the int. All right, so that's changing their value, and it's going to take it to the lowest possible value. Now, since these are unsigned numbers, they're going to go all the way back down to 0 in this case. If they were signed numbers and they were at their maximum, they would be at the lowest possible negative number. I also want to display the output of each of these values, and so instead of typing all of this again, I'm going to do some copy and paste of this section. And copy and paste is great for saving time, but we do have to be careful to change the parts that need to be different. So now I'm not working with underflow, I'm working with overflow. So really just the comment needs to change here, or the description that will be displayed on the screen. As far as displaying the values of the variables, that's going to be exactly the same as before. So now let's run the program and see the overflow in action. All right, so I still have my underflow numbers up there at the top, and now I'm seeing 3 zeros for my overflow values. So we went from 0 to the highest possible value, back down to 0, the lowest possible value. And now I want to show you something with the doubles, or the floating point numbers. I'm going to get that little box out of my way. And so I'm going to put a comment here in the code because now we're doing something else. And we're going to work with floating point numbers out of range. Something like that works for a comment about what I'm about to do. And so what I'm going to do is I'm going to take the number 10, which is the current value of the float and the double, and I'm going to square it. And I'm going to continue to square that number until I get out of range. So I'm going to again put another message out on the screen so that I know what I'm looking at. And I think I'm going to go ahead and add a \n to put a line break in front of this. And I'm going to say squaring 10. And then another \n. End L would also work here perfectly fine. So for the float, I'm going to set its value equivalent to its current value squared. So I'm going to use the pal function to square the number. The base is going to be its current value, and the exponent is going to be 2 to square it. I'm going to do the same thing with the double. I'm going to use the pal function to square the double. And now that I have changed their values, I'm going to display them on the screen. And in this case, I'm just going to put them side by side. They're going to have the same value until they get out of range, so I think I'll be able to read that okay. All right, now before I continue, I'm going to go ahead and test this and make sure it's doing what I want before I go ahead and then start squaring and getting it really big. So I'm going to compile and test this here real quick. I won't have an overflow or be out of range at all. But what I see here is it says squaring 10, and then I see the 100 and 100. Well, 10 squared is 100, so it looks like that's doing what I want it to do. And always when we're writing programs, we want to stop and test everything we do, because if we write a lot of code before we test, it's going to be a lot harder to find our errors. So now what I'm going to do is I'm going to do what I just did again. And in general, in programming, we don't want to have repeated code. So whenever we have something we're doing again and again, we're usually going to use a loop or a function. But since we haven't worked with loops and functions yet, the only option I have is to do copy and paste. So this would not be considered good programming, but if you don't know how to do a loop or create a function, then this is really your only option. So I'm going to begin by, I'm going to copy these 4 lines of code, the 2 lines where I'm calling the PAL function, and the line that displays the value, as well as the blank line below. Control C to copy that. And now I'm going to just paste this in. And I'm going to paste it 8 times so that I have a total of 9 of these. So that was 1, 2, 3, 4, 5, 6, 7, 8. Because that's what it's going to take for the double to go to infinity. All right, get rid of that extra blank line. And so every time, because we're setting it, we're changing the value of the variable, we can continue to square it, and we're going to see these numbers get larger and larger until we run out of space. So let's see this. All right, and so what I'm seeing now is after the 100s, I had 10,000. Now I'm starting to see numbers in scientific notation. And it says 1 to 10 to the 8th power, meaning I have 8 zeros after that. That makes sense. I had 4 zeros. When you double 4, you're going to have 8, so we're going to go up to an exponent of 8. And I could change the program to force it to use fixed notation and not show this scientific notation. But for what we're doing here, that would be fine. And I really don't want to write 256 zeros anyway. So we had 10 to the 8th, 10 to the 16th, 10 to the 32nd power. But when we doubled it again and went from 32 zeros to 64 zeros, the float ran out of space. And now it shows a value of INF, or infinity. It's not truly infinity, but it's representing infinity. The double has twice the storage as the float, and so it continues on. And you can take a double up to 10 to a power that's in the 300s. So I see here at the end, the last one I saw with a value was 10 to the 256th power. After that, when I doubled it, now I see infinity for the double as well as the float. So with the integers, we see the wraparound, but with the floating point numbers, what we'll see is a value of INF for infinity.